RMCLink is a powerful tool that can be used for communicating with an RMC Motion Controller. In this video, we'll go through how to use RMCLink to establish communications between MATLAB and an RMC. We'll cover basic reads and writes, sending commands, and reading plot data. Once RMCLink has been downloaded, browse to the folder on your desktop. Next, choose Samples, MATLAB, and then choose which of the three RMC controllers you'll be using. For this video, we'll be using the RMC 200. Each of the controllers have examples on basic communication, sending commands, and uploading plots. We'll start with the basic reads and writes. First, we create the RMCLink server COM object. Next, select the controller and set the IP address. After that, we establish the connection. Reals, dwords, and dints can all be read or written with this MATLAB example. Simply select the address and the length of the read. For instance, in this line, we'll read from register 256.20 with a length of 2. We'll be using this line to read the actual position and velocity from the RMC 200. In this next line, we're reading the raw counts from the RMC 200 in the form of a dint. And here we are reading the status bits in dword format. Registers can be written to the RMC in the same way. Here we are writing an array of reals, dints, and dwords. Next, we'll run and verify this program. Looking at our command window, I can see that my actual position and velocity were read as 15 and 0. My raw counts are 30,200, and my status bits are as seen here. Opening RMC tools, I can confirm that my status bits, actual position, actual velocity, and raw counts are all what was read from MATLAB. Furthermore, going into my variable table, I can confirm that my writes also went through and that the current values have been updated accordingly. Commands can also be sent to the RMC from MATLAB in the same way we would use the command tool here. To send a command, we'll need to specify the command number and any parameters associated with it. First, we'll send a move absolute command. To do this, we need to select a command number of 20 and specify the position, speed, acceleration, and deceleration. Opening the sending commands example, we see that an array is being assembled and sent to the command area at register 16. Sending to the command area is the same as issuing a command from our command tool. We can see that a number 20 command, move absolute, is being sent with a position of 5, a speed of 20, an acceleration of 100, and a deceleration of 100. When we run this example, we'll see that the move absolute command has been sent to our RMC. With our event log in RMC tools, we can confirm that our move absolute command has been sent. We can see that we're going to a position of 5 at a speed of 20 with an acceleration and deceleration of 100, just as we specified in MATLAB. We can also look at our status registers and verify that our position is now at 5. Next, we'll look at what it takes to transfer plot data from the RMC to MATLAB. We have two plotting examples available, the basic plot capture and the advanced, which we'll be going over now. First, we need to establish a connection, just as we've done in the previous two examples. Then, choose the plot to capture. We then look at the plot state and wait until the RMC is done with the plot capture to start reading data. Next, we write a 1 to the upload mode status register. This sets the upload mode to triggered and sets the current index to 0. We do this so that when we start our read, we start from the beginning of the recorded plot. After this, we set the requested read samples. Since the plot is a large file, we will be doing many small reads. The requested read sample value represents the number of samples per dataset per read. Leaving this at 50 will be just fine for this example. After that, we determine the number of datasets we are attempting to read. The length of each read is then calculated. The total number of samples is determined, and a suitably sized matrix is created to hold the plot data. Next, by looking at the requested read size and the total number of samples, the individual reads needed are calculated. After this, the reading begins. If the samples don't divide evenly by the requested read samples, the remainder is then read at the end. With all the plot data read, we are now able to read the loop time from the controller, determining our sample spacing. After this, we set the desired color for each of our datasets. This example has been set up to plot and label the target and actual position and target and actual velocity. If there are more datasets present on the RMC Tools plot, they will also be plotted but without labels. They can, however, easily be added to the legend here. Next, we'll run our example, capturing a plot from the RMC. This RMC has been purposefully detuned, making it easier to see the target and actual position and target and actual velocity. The position and velocity are plotted on their own scales, and each of the data items can be seen on the legend here. We can zoom in and manipulate data just as we would in RMC Tools. In conclusion, RMCLink is a powerful tool that can be used for communications between MATLAB and a Delta RMC Motion Controller. With our examples, you can quickly and easily establish a connection, read and write data, send commands, and even capture a plot.